Okay, so this morning we're going to look at adding fractions with unlike denominators. So the other day, Monday, we looked at adding fractions with the same denominator, which was quite simple, and you did a really good lesson on that. And what we're going to do today is use what we learned then and apply it when we add fractions with unlike denominators. Okay. So let's start with something fairly straightforward like a third plus a half. Now, if I had $1 for every student that wrote that a third plus a half is 2/5, I'd be very rich. Because what some students do is they look at it and they think, oh, well, I'll add the top numbers together, that gives me 2, and I'll add the bottom numbers together, that gives me 5. That's not how you do it at all. What we have to do with these fractions is we have to make them the same. We can't add them together at the moment because they're different. It's like when I gave you the example with the apples. If you've got 3 apples and 3 apples, you can add them together to make 6 apples, can't you? Apples, 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 apples in the answer. If you've got 3 apples and 3 oranges and you add them together, what would you have to say?
6 pieces of fruit.
6 pieces of fruit or 6 fruits. So we've changed apples and oranges to the same thing, to fruits, in order to be able to add them together and tell us what the total is. Okay? So now we've got thirds and halves. And we need to make the thirds and the halves into the same thing so that we can add them together. Now, that means we need a new denominator. A new denominator. Can anyone give me an idea of what that new denominator might be? Anyone got an idea of what the new denominator might be and how we do it? Brianna?
6.
The new denominator is 6. How did you work that out?
Because 3 and 2 both go into 6.
Very good. So the new denominator is 6. That's because 3 divides into 6 and 2 divides into 6. Now we could have also chosen 12. Because 3 goes into 12 and 2 goes into 12. We could have also chosen 24. Because 3 goes into 24 and 2 goes into 24. But what's special about 6? Why is that the best one to choose?
Because you don't want to have like a bigger fraction, you want it to be simple.
Perfect, that's right. We don't want a really big fraction because what do we have to do to really big fractions? We have to simplify them, don't we? So we don't want to kind of make it more complicated than it needs to be. So what we're looking for, this is the word we're looking for, is the lowest common, that means they both share it, denominator. The lowest common denominator. And generally, you can find that by multiplying the 2 denominators together. Okay? So 3 times 2 is 6. That gives you the lowest common denominator. Now, once you have done that, what we need to do then is we need to convert 1/3 into an equivalent fraction over 6 and a half into an equivalent fraction over 6. And the way we can do that is by cross multiply. So this is what we do. We go 1 times 2 is 2. 3 times 1 is 3. So that leaves us with 2/6 and 3/6, which gives us 5/6. Now, if you don't understand this the first time, don't worry. The class yesterday took them 3 or 4 goes and then suddenly clicked for all of them. And that was fine. So just let me explain a few more examples. Okay, let's do this one. Let's have a quarter add a third. Okay. Now, can we just add them together? We can't just add them together, can we? Why not?
Because they've got different denominators.
Well done, they've got different denominators. So we need to give them the same denominator. What do you think that denominator might be? What's a number that 4 and 3 divide into? Dane?
12.
12, yeah. Okay. Now, because we've multiplied 4 by 3 to get 12, we can do the cross-multiply method, okay? If when your lowest common denominator isn't the product of those two, you can't do cross-multiplying, and I'll show you an example of that later, but let's just look at this method first. So, you always start at the top left. 1 times 3 is 3. 4 times 1 is 4. So now we've got 3 twelfths and 4 twelfths. Same type of fraction, same denominator. That means we can just simplify it to 7 twelfths. Well done. 7 twelfths. Okay. Did it appear a little bit clearer with the second example?
Yeah.
Yes, right. Okay, let's try this one. 2 fifths, add a third. Okay. Fifths and thirds, are they the same?
No. Yes?
No, they're not, are they? So what do we need to do? What do we need to do? I was just waiting for someone else to answer, because you answer all the questions, don't you? Okay, so fifths and thirds, same or different? Different. We need a new denominator. What is our new denominator going to be?
15.
Good boy, 15. And how did you find that?
Well, I just added up, well, like went in like threes, so I got
So you
15.
multiplied those two together, didn't you?
Well, yeah, I could have done that, but no, I just went up in threes because I knew that 5 would, it needed to end with 5.
Oh, that's a good method. Yes, that's great. So what Jack said is that he went up in threes. He did 3, 6, 9, 12, 15. And that was the first one that ended in a 5 or a 0, because he knew that if it was in the 5 times table, it had to end in the 5 and the 0. But the easier way is just multiplying them together. 5 threes are 15. Okay, we can do the cross-multiply method. 2 times 3 is 6. 5 times 1 is 5. So now we've got 6 fifteenths and 5 fifteenths. What have we got all together? 11 fifteenths, that's right. Okay, do we have to simplify that?
No.
No. Okay. Everyone understanding? Okay, great. Let's have a look at another example. We'll have 2 sevenths and 3 fifths. Okay, sevenths and fifths, same or different?
Different.
Different. They're unlike, aren't they? So, we need a new denominator. What's my new denominator going to be?
35.
Well done, 35. Did you just do that by multiplying them?
Yeah.
Yep, 7 fives are 35. Okay? Now then, 2 times 5 is 10. 7 times 3 is 21. So, we've got 10 35ths and 21 35ths. What does that come to?
31.
31 over 35, that's right. Okay. Who's sort of seeing it now and thinking, oh, it's quite straightforward. There you go, told you. Right. Now, I'm just going to give you one, though, that's a what's the word when it doesn't follow the rule? An exception. I couldn't think of the word exception. An exception to the rule. So say we've got something like a quarter and a half. Now, you can do that in your head, can't you? What would it be? What's the answer?
3/4.
3/4, that's right, isn't it? Because you've automatically changed it to quarters in your head. Now, if you looked at it, but you can do it in two ways. You can do it the way that I've just taught you, by multiplying the denominators. So 4 times 2 would be 8. But if you remember, Jack said that the answer was 3/4. So that's a bit different, isn't it? But listen. So then we've got 1 times 2 and 4 times 1 is 4, which gives us 6/8. And then what would you have to do? Simplify it to 3/4, that's right. Now there is another way of doing this. If you've got a quarter and a half, what you can do is you can, because what is the actual lowest common multiple of 4 and 2? What's the first number that appears in both their times tables? Jacob?
Oh.
4, that's right. So our new common denominator is 4. If you notice, it's not 8. So, did we get that 4 by multiplying the 4 and the 2? No, so we can't cross multiply. You can only cross multiply like that when you've multiplied those two together to get the denominator. Okay? But what you would do here is you would use your knowledge of equivalent fractions. So the quarter stays the same, doesn't it? Because obviously we're dealing with quarters, so we know that that's 1 quarter. And what you would do then is you would say, well, what has happened to the 2 to make it 4? It's been times by 2, so I'll times the numerator by 2, and that gives you 3 quarters. Okay? I think the easiest way to do it, unless the numbers are very big, is this way. Okay? Because you've got one method to learn then, and you don't need to worry about equivalence. Right, so let's have a go and just I'll do one more fairly straightforward one, and then we will do a more complicated one. Okay, 2 ninths add 2 fifths. So we've got ninths and fifths. Same or different? Different. Okay. Need a new denominator. What's my new denominator going to be? Bentley.
50? No, 55.
5 nines are...
Oh. 26. Oh my god, I've gone blank.
Jack? 45, that's right. You were so on the right track, Bentley. You were so on the right track. Okay, so we've multiplied the denominators together. That means that we can cross multiply. So 2 times 5 is 10. 9 times 2 is 18. And then we just add them together. 28 over 45. Can we simplify that? No, because they've got no common factors. Okay. Right then. Let's take it up a notch. Not very hard. No, that's good. So 3 quarters plus 5 sevenths. Now there's only one more step in this one, okay? And you know how to do it, so there's no need to worry. You've just got to remember to do it. So let's follow the process that we've just learned. What is my new common denominator? 28, that's right. So 4 times 7 gives us 28, which is our new common denominator. 3 times 7 is 21. 4 times 5 is 20. So we've got to add these together now. So it's 41 over 28. So tell me, what is the step that we need to take now that we didn't have to do before?
Put it into a mixed fraction.
Very good, you put it into a mixed fraction. So how many 28s are there in 41? There's 1, and how many left over?
13.
13, that's right, so 13 28s. So the only difference here is that when we added the numerators together, it made the fraction bigger than 1. So we had to convert it to a mixed number. Okay? Everyone with me with that? Do you want to do one more example like that? Okay, let's have 3 eighths plus 4 fifths. 3 eighths plus 4 fifths. So what's my new common denominator? Brandon? 40. Well done. 40. So we got that by multiplying those, so we can cross multiply. 3 times 5 is 15. 8 times 4 is 32. That comes to 47 over 40. What do I do now?
You make it a mixed number.
And that is...
1 and 7/40.
Brilliant. 1 and 7/40.